Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 8 from the May-June 2020 International A-Level Cambridge 9709. This is Pure Mathematics 1 paper, variant 2. And this question here is about this curve and this shaded region. And it's told us that the diagram shows part of the curve y equals 6 over x. The points 1, 6, and 1 and 3, 2 lie on the curve. The shaded region is bounded by the curve, the lines y equals 2 and the line x equals 1. So that's what the shaded region is bounded by. And we've got to find the volume generated when the shaded region is rotated through 360 degrees about the y-axis. So it's about the y-axis. I put that in bold because most questions that you see on this is rotating about the x-axis. This is rotating about the y-axis this time. Okay, so first of all, what we need to understand is the following: that when we take an area and rotate it about either of the axes, then we have to consider the following. So just imagine there was not this line here. It was just the whole of this region here that we have to rotate about the y-axis. So what we can do is we consider from the y-axis to that point a strip that is so thin, that we call its thickness like a small amount in the y direction. And this length here is the x value of this point, basically. This would be x. Okay, the length of this line would be whatever value of x is at this point. If we took this thin strip and we rotated it around the y-axis, it would form a kind of cylindrical shape. Let me try and make that a bit straighter. Okay, it would form a kind of cylindrical shape. Okay, it's kind of like going into the page now, three-dimensional. And it would, be a very thin cylinder. I've kind of exaggerated its how thick it is. It's actually thinner than that. We've got to think of it as really small, really thin, right? So that is dy, and the radius of this cylinder that's formed when this rotates around the y-axis, is x. And we know that the volume of a cylinder, is, if that's r and that's the height or the thickness of it, is pi times r squared, which is the area of the cross section, times h. So in this case, the volume of this small little cylinder would be pi times r squared. Now r is equal to x now, so it'll be x squared times the thickness of the cylinder, which is dy. Okay. Now, if I want to add up all of the cylinders from the bottom of this shape to the top of this shape, then I need to find the sum, which the integral sign actually means sum. That's what it's like an S shape. Okay, of all the cylinders between y equals 2 and y equals 6. Okay, between whatever this is, let's call this A and B. Okay, so from B to A, all of the cylinders that we can get from, adding all of these the volumes of all of these cylinders together, that will give me the volume of this whole shape, which would be kind of like a bell shape around the y-axis. However, in this case, we have like a part of it missing. So we're going to have like a tire kind of shape. So where this stops, there's going to be like a hole in the middle. Okay, so this cylinder will have this hole. So it'll be kind of like a tire type of shape, right? So you're going to have this hole in the middle of it, right? And the radius of this inner part of the cylinder, is going to be the distance from here to this line. So let's call the distance from there to the outside, the curve on the outside, the one furthest from the y-axis, let's call that x1. And the distance between here and this part here, let's call that x2. So it's like you have a circle and you have an inner circle. You have x1 and x2. And if you want to find the volume of this shape, okay, that's x1 and that's x2. Now the volume of that shape is going to be pi times, and this is, we're going to call this dy, it's going to be pi times the outer radius, which is x1 squared dy, minus the volume of the whole, the part that's missing, is pi times x2 squared dy, okay, which will give you pi times, you can say x1 squared minus x2 squared dy, okay? So the volume, if there's a bit missing, is going to be, I'll write the pi on the outside, between b and a of, you're going to have x1 squared minus x2 squared dy, all right? So that would be the volume of something like this. Now there's an alternative way of doing this, is to find the volume using this, of the whole thing, and then take away the volume of this cylinder that's going to be formed over here. If you draw the cylinder from the top to the bottom, you'll have a cylinder of radius, okay, which radius 1 and height from 2 to 6, which is 8. Okay, you can find the volume of that cylinder, take it away from the volume of this, and you get the same answer. Okay, but I like to teach this method because sometimes there will be two curves, in which case a straight line won't make a cylinder. Okay, it will make another type of weird shape, so you'll have to understand how to do this in those type of cases. And I've seen some of those cases come up recently. So that's why I like to teach this method, so people understand. It's like, you know, you have a situation like this. So whatever happens to the second line, whether it's a straight line or a curve, it will apply to that. So I'm going to use this formula V equals pi times x1 squared minus x2 squared, okay, with respect to y, between the limits a and b. So in this case, our formulas that we're going to use are y equals 6 over x, and we have the line. Now this line here is x equals 1. As you can see, this is the line as they told us, x equals 1. This line over here is x equals 1. Okay. This is the line x equals 1. All right, so we have to use that line. Okay, and our limits are going to be between 2 and 6, because between the line y equals 6 and 1, 6 and 3, 2. So the lines y equals 2 and x equals 1. So where they intersect, the line of the curve is 1, 6, and that's the point as far as we need to find the volume, okay, of revolution from the intersection point down to this point when y equals 2. So our values here are going to be 6 and 2. So our a is 6. A is 2 and then B is 6. So B is equal to 6 and A is equal to 2. And we have the line x equals 1. So what we have to do is the equations that we have to be in terms of x, because I have to put, it has to be x in terms of y. So x has to be the subject in terms of y, because we're going to integrate with respect to y. So this I'll express as x equals 6 over y. And this is already x equals, so that's fine. So now I can say the volume is equal to, and don't forget the pi, you're going to have 6 and 2 as my limits. I'm going to have x1, which is, this is x1, the one that's further out from the axis is x1. So this is going to be our x1, okay, when we make x the subject. So x1 is going to be 6 over y, that squared, minus x2, which is just 1, and that squared, and that has to be integrated with respect to y. Okay, so let's just get it ready for integration. You have pi, and here you have 6 and 2, and this is going to be 36 over y squared minus 1, integrate with respect to y. Let's just get it ready. One more thing to do to make it ready. Don't forget the pi always. 2, 6. Now this is going to be 36y to the power of negative 2 minus 1, and you're going to have dy. We want to make the variable on the numerator, so it's easy to integrate. Now we have to integrate this with respect to y. So once we start integrating, don't forget the pi. Now the integral sign is now replaced by a square bracket. 36y to the power of minus 2 is like add 1 to the power, so it becomes to the power of, so whoops, 36, not 3. Don't make silly mistakes like that. So 36 times y to the power of negative 1, add 1 to the power, divided by the new power, minus, and you're going to have 1 becomes y, and then you have your limits between 6 and 2. That's going to be pi times, and just simplify this a bit, that's minus 36 over y minus y between 6 and 2. Now we can evaluate this, so don't forget the pi, as I said always. You'll have pi. Now we're going to put 6 into here. So we'll have minus 36 over 6 minus 6. Okay, and then you're going to have minus, and now we're going to put 2 in here. So you have minus 36 over 2 minus 2. And that gives us pi times, that's going to be minus 6 minus another 6 minus, and here you're going to have minus 18 minus 2 minus 20. Sorry. Minus 18 minus 2, that's negative 20. So we have, that's going to be minus 12 plus 20. So you have pi times minus 6 minus 6 is minus 12. But then you got minus and minus, which is plus 20, which gives us 8 pi. 8 pi units cubed. Cubic units, because we're talking about volume. So there is the answer to this question. And that completes this integration, or this volume of revolution of the shape when it is rotated about the y-axis 360 degrees. Okay, so that's how we deal with such a question. Now, what's 8b about? Let's have a look. Okay, part B is to do with differentiation. So I'm going to answer part B in a separate playlist, a separate video, so I can save it in a different playlist. So part A is all about integration. So if you want to find other questions from this paper, including part B of this question, you can go to the playlist that will appear in the top right of this screen. Other questions dealing with volumes of revolution from P1 of Cambridge, you can find in the playlist in this area at the end of the video. Other questions involving volume in general from my P1 collection, you can find in this, involving integration, in general, you can find in the playlist over here. You can subscribe to my channel by clicking on this link. As I said, part B will be following in a separate video, which you can find in the playlist up there. Thank you for watching, and see you soon.